Alright, I'm going to go over the Unit 3 review for you in case you have questions there. The first part is just asking for a second derivative. It's a pretty straightforward problem as far as what to do, but it gets a little intensive with algebra. So let's look at part A here of this first one. So when you take that derivative, the derivative of -1 is just 0, so that part goes away. And you have to use a quotient rule on the second part. So you're going to have x times the derivative of y squared, which is 2y, and then it would also have a dy dx there with it, minus y squared times the derivative of x, which is just 1, all over x squared. Okay, you can see that that does not look like the answer that they're telling you that you need to get, and that's because you need to plug -1 plus y squared over x in for dy dx. So when you do that, you'll have 2xy times -1 plus y squared over x minus y squared all over x squared. And your best bet here is to distribute. And so that is going to give you -2xy plus, right here what you're doing, I'm going to do it over to the side here, is you're saying 2xy times y squared over x. And so there's 2xy's in the numerator. The x's right here are going to cancel out. And so you're going to end up with 2y to the third for that part. And then you get minus y squared all over x squared. And if you look at the answer you're supposed to have, it looks almost like this. It's just in a different order. So you always want your answer to match what they give you exactly. So we're just going to rewrite it in order, even though we recognize this is already the same. So we'll have 2y cubed minus y squared minus 2xy all over x squared there. I feel like a implicit differentiation is one that they may very well give you because the calculators don't do those for you very well. So I would look for one of these. Make sure whatever you get here at the end matches your answer over here. Okay, the second part and the only other part of this problem that we're going to do is part B. We're not going to do C and D. This is actually a BC question with Taylor series stuff that we don't have to do. So I couldn't not assign that part because that wasn't an option, but you don't have to do part C and D on this one. So for part B, it says let y equals g of x be the particular solution to the differential equation. With g of 4 equal to 2, does g have a relative minimum or relative maximum or neither at x equals 4? And we are supposed to justify our answer. We're not actually going to solve this differential equation. In fact, if we did, we wouldn't really be able to solve it. They do give us some really important information right here. G of 4 equals 2. This problem, when I first tried it, I really had some trouble with it because when I think of finding maximum minimums, I think of doing the first derivative test where I need to know if something changes from negative to positive. Well, that's not easy to do when you're dealing with something that's not a function right here like we have in this case. So first of all, in order to have a maximum minimum point, your derivative has to equal 0 at that point. So the first thing you're going to do is you're just going to take the derivative. And you're going to use this notation right here, x, y equals 4, 2. And you're just going to plug in 4 and 2 into your derivative. And so you'll get -1 plus 2 squared over 4, which is going to be -1 plus 1, which is 0. So that tells you you do have a critical point here. So what I was originally trying to think of is how I could put something on a number line and tell if we go from positive to negative and whatnot. But we cannot do that because we need to have an x and a y coordinate, so we can't just look at the x coordinate or the y coordinate for this. So you have to rely on a test that we did not spend quite as much time on, and that is the second derivative test. So the second derivative test, first of all, tells us we have to be dealing at a critical point, which we are here because our derivative equals 0. If the second derivative is less than 0, that tells us that g of x is concave down. And if we know it's concave down, then it would have a maximum point. Or if we know the second derivative is greater than 0, that tells us that g of x is concave up, which tells us that we would have a minimum point at that point. So we need to take our second derivative, which fortunately we already have because we found it in the last problem. And even if you couldn't do the last part A, it gave you the second derivative, so you can use it for this part as well. So we're just going to plug 4,2 into that second derivative. So we're going to say d squared y over dx squared, such that xy equals 4,2. And so we're just going to plug in to that derivative that we had. Let me scroll up here so we can see it. So you'll have 2 times 2 cubed minus 2 squared minus 2 times 2 times 4 all over 4 squared. And so you have to simplify this at least enough to be able to tell whether it's positive or negative. So 2 to the third is 8, so it'll be 16 minus 4 minus 16 all over 16. So you're going to end up with negative 4 over 16, which is negative 1/4. Okay, so what we're going to say here, I'll type so we can see a little better. We will say since dy dx equals 0 and dy or d squared y over dx squared, that's my second derivative, is less than 0 at the point 4,2. G of x has a relative, in this case, since our second derivative is negative, means concave down, which means that you'll have a maximum point there. So g of x has a relative maximum at this point. Okay, so and you can say something about by the second derivative test. I don't know that it's necessary, but we could say so by the second derivative test, g of x has a relative maximum at this point. So that's all you'll do for the first one. Skip C and D. You don't have to know how to do those. Let's go on to question 2. Okay, question 2 is more implicit differentiation. So at first we just have to take our derivative here for part A. So we'll have 4x plus 6y, and we have to put a dy dx with that one, minus, depends on how you want to do it here. I'm going to use the 4 pulled out. You got to use a product rule for this x times y. So you got to do x times dy dx plus y times 1. And this will all equal 0. So we've got 4x plus 6y dy dx minus 4x dy dx minus 4y. equals 0. So we're going to keep our dy dx stuff over here on the left. We'll go ahead and factor it out. And I'm going to move this 4x and this negative 4y over to the other side. It'll become a positive 4y and a negative 4x. And last, we're going to divide by that 6y minus 4x. Well, actually, not quite last, because that gives us 4y minus 4x over 6y minus 4x, which technically is correct. And if they had not told us what our answer is supposed to be, we could have left it like that. But if you look at your answer over here, you're supposed to have 2y, 2x, 3y, and 2x. All of these numbers right here are divisible by 2. So you need to reduce them. So you got 2y minus 2x over 3y minus 2x, like so. And so we have shown that that derivative is equal there. Again, always make sure it matches perfectly. B says find the slope of the line tangent to the curve at each point on the curve where x equals 6. And so for that derivative, our problem here, slope of the tangent line means we just plug that value into the derivative. Super easy. Except for, if we're plugging into this derivative, I've got to have an x and a y coordinate. So I cannot plug into this derivative unless I also know the y coordinates here. So what I'm going to have to do first is I'm going to have to find the y coordinates. And to find those y coordinates, you're going to have to plug into the original equation. So you're going to have 2 times 6 squared plus 3y squared minus 4 times 6 times y equals 36. And so that is going, let's see, 6 squared is 36. This will be 72 plus 3y squared minus 24y equals 36. And let's move everything over here to the left-hand side and put things in order. So we're going to have 3y squared minus 24y plus 36 equals 0. And so we need to factor that. Before you factor though, I'd divide everything by 3 just to make the numbers smaller and easier to deal with. So you'll get y squared minus 8y plus 12 equals 0. And so if we factor that, we're going to have a y here and a y here. And so 6 and 2, so minus 6 minus 2 is what's going to work. So we'll get y equals 6 and y equals 2. So our points that we're going to be considering are at 6, 6 and 6, 2 for this. X coordinate 6 for both, and then you got your 2 different y coordinates. So you first have to find those points. Now you want the slope of the line tangent to the curve at each one of these points. So now's when you're going to plug into that derivative. So dy over dx such that xy equals 6, 6. This one is going to be 2 times 6 minus 2 times 6 all over 3 times 6 minus 2 times 6. Technically, you don't even have to simplify this. I'm going to. You get 12 minus 12 over 18 minus 12, which is going to give you 0 over 6, which is 0. For the second point, you're just going to do the same thing with the different points. Make sure you label it like I'm labeling it here. Don't just write things down without labeling it, because then they do not know for sure that you knew that's the point you were plugging in, and you may not get full credit. So we'll have 2 times 2 minus 2 times 6 over 3 times 2 minus 2 times 6. And so we get 4 minus 12 over 6 minus 12, which will give us negative 8 over negative 6, which will be positive 4 over 3. And so that is our slope at that point. So we have our two answers for part B. All right, let's continue on. For part C, we want to find the positive value of x at which the curve has a vertical tangent line. Show the work that leads to your answer. So if you have a vertical tangent line is going to mean that the denominator of your derivative is going to equal 0. So the first thing you would have to do for this is set that denominator, 3y minus 2x, equal to 0. Now, you can't solve that equation because it has an x and a y, so you can't get the answer right away. But we're asked to find the positive value of x at which the curve has a vertical tangent. So we know this has to be true. We have to figure out what point that happens at, and we want to know the x coordinate. So what we really need to do is we need to do like substitution. We're going to plug this equation into this equation, and we want to get x as our answer. So what I'm going to do is I'm going to solve this equation right here for y. So that'll be 3y equals 2x and divide by 3. Technically, you could do this either way. You could solve for x instead. It's just going to be faster if you do it this way because you're going to still have an x in the problem, and therefore you'll get the answer with the x there, and you won't have to plug anything else back in when you're done. So you're going to take this information, and you're going to plug it into 2x squared plus 3y squared minus 4x y equals 36. You're taking this right here, and you're plugging it in right here and right here for your y's. So you got 2x squared plus 3 times 2/3 x squared minus 4x times 2/3 x equals 36. And so 2x squared plus right here, you're going to have 4 over 9 x squared. Whenever you square this, you got to square the 2/3 and the x. And then right here, 4 times 2/3 is going to give us 8/3 x squared. And you'll be able to use the calculator, so I would right here. Right here, this 3 times 4/9, that 3 and the 9 can reduce, so you got 4/3. So you got to do 2x squared plus 4/3 x squared minus 8/3 x squared equals 36. Again, you could just type it in the calculator or do it by hand, either one. You should get 2/3 x squared when you put all of that stuff right there together. You are going to divide both sides by 2/3, or I like to think of it as multiplying by 3/2 on both sides. And so you're going to get x squared equals 54. And then you are going to square root both sides, so x equals the square root of 54. You typically would put a plus or minus in front of that, but the question asks you for the positive value, so you don't need it here. The answer key rationalizes that square root, but you do not have to do that. I just leave it like this right here. Okay. And then we have one more for D. It says, let x and y be functions of time t that are related by the equation that we have been using so far. At time t equals 1, the value of x is 2, the value of y is -2, and the value of dy dt is 4. The value of dx dt at time t equals 1. So this is a creative question right here, and this is one of the questions that was flagged in AP Classroom for you to pay close attention to, and I could see, especially with them really trying to condense the test, how this would be a really good question to put on there, because they can ask you implicit differentiation questions with it, but they can also ask you related rates problems with it. So everything we looked at so far, all this derivative stuff we found up here, we were doing dy dx. But if you'll look here, a t has been introduced. It's a third variable. And they're telling us things like dy dt and dx dt. So what you're doing here is a related rate problem. So you have to go back to the beginning and start from that equation, the 2x squared plus 3y squared minus 4xy equals 36. And so what you're going to do is, instead of taking the derivative with respect to y like you did on part A, you're going to take the derivative with respect to t. Okay, and for related rates here, when you take the derivative, it's a lot like implicit differentiation, except for you're taking the derivative with respect to t, so everything needs that derivative term there with it. So you would have 4x, and then you have to put dx dt with it. And then you'll have 6y, and you put the dy dt with it. And then you're going to have 4 times x dy dt, because the derivative of y is dy dt, plus y times dx dt, and this is going to equal 0. Okay, and then the problem gives you a lot of information. You are looking for dx dt. So dx dt is right here, and also right here, and that is what you're looking for. The good news is they gave you every other piece that's in this equation. So they tell us that, let's see, x equals 2 and y equals -2, and dy dt is 4. So we just have to plug that information in. So you'll have 4 times 2 dx dt, because that's what we're looking for. We're not going to replace it. Plus 6 times, they tell you y is -2, and they tell you dy dt at this time is 4, minus 4 times 2 times dy dt, which is 4, plus y, which is -2, times dx dt, and that all equals 0, even though I ran out of room. So you got 8 dx dt. Let's see, it's going to be a minus. So let's see, you'll have -48 right there, minus 4 times 8 minus 2 dx dt equals 0. You'll need to distribute here. So you got 8 dx dt minus 48 minus 32 plus 8 dx dt equals 0. And so if you put those two 8 dx dt's together, you get 16 dx dt, and you're going to have minus 80 equals 0. We're just about there now. So you got 16 dx dt equals 80, and you're going to divide both sides by 16. And so dx dt equals 5. And that is your answer for part D. So hopefully this was helpful on these questions. Look back over and make sure you understand them, because these are things that AP's putting out there that they're saying are similar to what you'll see on the test this year.